Module 2, Lesson 3, Interpreting and Computing Division of a Fraction by a Fraction, and looking at more models. So far we've worked mostly with whole numbers divided by fractions, fractions divided by whole numbers. We're now going to step into fraction by fraction division. And we're going to use fraction bars, tape diagrams, and number lines to show the division of fractions by fractions. And we're going to focus on fractions that have common denominators. Common meaning they have the same denominator. I can explain connections between the multiplication and division of fractions, so continue to explore the relationship. And this third ICANN statement focuses on measurement division. We're answering the question, how many groups can we make, rather than how many in each group. All right, so taking a look at models to represent 12 divided by 3. So we have our measurement division, which answers how many groups we can make. And we have our partitive division, which answers the question, how many would be in each group? I hope that I'm saying and or expressing those correctly. So thinking of these, if I were like dealing cards, partitive division would answer the question, how many cards would each person get? And measurement division would be answering the question of how many groups could I make. So if I were to do a model here, start with the measurement division, I'm putting them into groups of 3, and the question is, how many groups can I make? And I would have 4 groups of 3. So this is a measurement division. Three is the size of the groups. And the quotient 4 tells me the number of groups that I can make. Now, if I were to think of this in a partitive division format, I've got 3 people and I'm trying to answer the question, how many cards would each person get? So I could think of it as first person, second person, third person, first person, second person, third person, first person, second person, third person, first person, second person, third person. And I can see that each person, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I can see that each person would receive 3 cards. So, sorry, 4 cards. So the 3 is telling me the number of groups. And the 4, the quotient, is answering the question, how many in each group? So looking at some possible examples, and everything in my life relates to donuts, it seems like. If there are 12 donuts and 3 people, how many donuts does each person get? So the 3 is telling me the number of groups to make. This is a partitive division. If there are 12 donuts and I put 3 on each plate, how many plates will be filled? This is a measurement division. They both have the answer of 4, but the answer of 4 means different things. I would much rather be in this group because I know that I'm going to get 4 donuts. So taking a look at some patterns, we're going to look at this concept of units, and we've touched on it briefly in some of the other lessons. And they're going to encourage us, as we explore this lesson, to look at unit form. So we have 8 divided by 2, and we probably just memorized that that is straight up 4. But we're going to think about this 8 and this 2, and we're going to think about what does the 8 actually count. And in this first problem, it's 8 ones and 2 ones, and when I divide, I will have 4 ones. And we can think of this, of course, as partitive or measurement, but right now we're focused more on the pattern than the type of division. So if I've got 8 tens, which is 80, and I've got 2 tens, which is 20, and I divide, I've still got 4. So I still wind up with 8 divided by 2. I just happen to know that the units that I'm counting are tens instead of ones this time. If I look at 8,000s and 2,000s, that's 8,000 divided by 2,000, and I've still got 4. But instead of writing out all those zeros, I'm saying, hey, I have these units here, and these units are going to divide each other out. They're going to cancel each other. If you remember back to some of the things that we did in Module 1 with unit conversions, we were looking for opportunities to have things divide away. So I'm still got 4 here. 8 tenths and 4 tenths. Well, this is 8 tenths. Oh, sorry, 2 tenths. And 2 tenths, and once again these units divide away and I still have a 4. And the same thing will happen with thirds. These thirds will cancel each other out and I will be left with a 4. So thinking of these fractions in unit forms, especially when we have common denominators, really makes dividing fractions much easier to think about. And we're going to take a look at some examples and do some models. And of course, I would probably be somewhat remiss if I didn't connect, hey, does this work with our multiplication? So let's take a look at this example here and see if we can pull in our multiplication observations that we had made. So it says we're going to write the expression in unit form. So unit form is 8 ninths divided by 2 ninths. And I will confess that I like writing in this fraction form like this, because then I can see that these ninths are going to divide each other away, and I will be left with 2 ninths, and I will get a quotient of 4. Now I am supposed to draw a model for this problem. So I'm going to use a tape diagram, and I'm going to indicate on here that I've got one whole, and I'm going to cut it into ninths because we are counting in ninths. Our units are ninths. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to come find my 8 ninths. And in measurement division, I would answer the question, how many groups of 2 ninths can I make? So I am going to go through and make some groups of 2 ninths. Here's 2 ninths, and here's 2 ninths, and here's 2 ninths, and here's 2 ninths. So I've got a group, a group, a group, and a group. And there are 4 groups. 4 groups of 2 ninths. So I can see a connection between the unit form and the model form. I can see that the ninths are going to cancel out, and I'm left with 8 divided by 2, and I would end up with 4. Now, of course, the question is, does this connect to some of this multiplication stuff that we had done? And we had been playing with this 8 ninths divided by 2 ninths, and we were testing whether or not it was equal to 8 ninths times 9 halves. And we get 72 eighteenths, and 72 divided by 18 is going to be 4. So there is a connection there, and I don't want to dive too much into the model portion of this, but exploring, hey, I'm noticing a pattern and there is a connection. So taking a look at example 2, write it in unit form. 9/12 divided by 3/12. And the 12ths are going to cancel, and I see that I'm going to end up with a quotient of 3. And I'm supposed to have a model, so I need some 12ths here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I know my pieces are never quite the same size, but it's a fraction, so we have to know that they're the same size. All right, so this is 1 whole, or 12/12. And it says we're going to take 9 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's my 9/12. And if I'm doing measurement division, I need to do some groupings here, groupings of 3/12. So 1, 2, 3, 1, 2, 3, 1, 2, 3. And I have found that I have 3 groups of 3/12. 9/12 times 12/3. Those 12ths will divide each other out, and I will have 9 divided by 3, which is 3. Just playing with that multiplication that we have been observing and noticing as a pattern in the last few lessons. Right, example 3, 7/9 divided by 3/9. 7/9 divided by 3/9. Now this one gets a little bit interesting. 7 doesn't divide evenly by 3. When I do 7 divided by 3, I get 2 1/3. So it's going to be interesting to see what does this look like in a model form. Because I think this is the first time we have run into this not dividing evenly. So we need to start preparing our brains for how we're going to handle this. Well, we're in ninths is our wholes. So 1, 2, 3, 4, 5, 6, 7, 8. So there is our 1 whole. And we've got 7 of these ninths. 1, 2, 3, 4, 5, 6, 7. All right, so there is 7 ninths. And I am supposed to put them into groups of 3. So there's a group of 3. And there's a group of 3. So I've made 2 whole groups of 3. And I need to ask myself the question, how much of another group of 3 do I have? I'm making groups of 3. So my denominator is 3. And I have 1 piece left over. So I have 2 1/3. Like I said, I'm pretty sure this is the first time we have run into not dividing evenly as we've played with the fractions. So I want to emphasize again that we go about our normal business here of making groups of 3. And because we are making groups of 3, the denominator right here is going to be a 3. And we need to count up how many pieces we've got left, 1 of them. So we have 1/3 of another group. If I had 3 full pieces, if I had 3 pieces left, I would have 3/3. But I don't have 3 pieces, I have 1 piece, which is 1/3. All right, taking a look here at exercise 1, we're going to write an expression to represent the problem and then draw a model to solve it. Let's see, how many fourths are in 3/4? So I've got 3/4, and I want to answer the question, how many groups of 1/4 can I make? Well, if I write it in unit form, 3/4 divided by 1/4, my units will cancel and I'll be left with 3. But I am supposed to have a model to represent my thinking, and on this one I'm going to go with a number line. So here's my 0, and I've got my 1 here, which I will have be 4/4, and I need to count by fourths. So here's 1/4, here's 2/4, here's 3/4. And I'm trying to answer how many fourths are there. Well, there's 1, 2, 3. So I've counted up by fourths. So there's 1, 2, 3. There are 3 1/4ths and 3/4. There we go. Write the expression in unit form. So 4/5 divided by 2/5. My units will cancel and I'll be left with 2. And I'm supposed to show this with a model. I think I'll try a number line again. You know what, I think I'm going to take a second here and play a little bit with my multiplication observation. 4/5, and I'm going to multiply by 5 halves. So these will cancel, and I'll have, well, the cancel might be a little bit going too fast there. 4/5 multiplied by, whew. So that gets me a 4 times 5 over a 2 times 5. The 5s will divide. I've got a 4 over 2, which will predict that I get a 2. I've got 2 predictions now for 2. Now I just need to work out a model here. I'll do a number line again. I need 1 whole, and that's 5/5. So I'll count by fifths. 1/5, 2/5, 3/5, 4/5. 1/5, 2. And we're counting by 2/5 this time. So here is 2/5, and here is 2/5 more. So I can see I've got 2/5 and 2/5. So I divide and I get 2 groups again. So still working out here. All right, exercise 3. Write the expression in unit form. 9/4 divided by 3/4. Now, something that I noticed right away, this 9/4 means I have more than 1. Because the numerator is greater than the denominator, as I draw my model, I'm going to have to count. I'm going to have more than 1. So I'm going to put my number line here, and it's going to have to go. I'm going to have to count up further here. I'm counting by fourths, and I've got 9 of them, and I'm not sure where that ends. So I think I'm just going to count clear up to like 5 here. 1, 2, 3, 4. Oh, help if I get my numbering right. 1, 2, 3, 4. And I need to make fourths out of these. And I need to count up 9 of them. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's my 9/4. Okay. And out of my 9/4, I need to be making groups of 3. So I'm going to count by 3s here. So 1, 2, 3. 1, 2, 3. 1, 2, 3. So I'm going to find out that I could make 3 whole groups, which matches over here. And then I could try out my multiplication. 9/4 multiplied by 4/3. 9 times 4, 3 times 4. And I've got 9 divided by 3, which is 3. And once again, these are lots of examples of measurement division. We're asking how many groups of a size can I make? All right, looking at exercise 4. 7/8 divided by 2/8. 7/8 divided by 2/8. There we go. And that's 7/8 divided by 2/8, which is going to leave me with a 7 divided by 2. So I should end up with a 3.5 here. But let's see what it looks like in a model. And I'm making eighths here. 1, 2, 3, 4, 5, 6, 7. All right, so this is my whole, my 1, and I have 7/8. 1, 2, 3, 4, 5, 6, 7. 7/8, and I'm supposed to make groups of 2. So there's a group of 2, there's a group of 2, there's a group of 2. So I've got 3 whole groups of 2, and I'm making groups of 2, which will leave me with a denominator of 2 then. And I've got 1 piece left over, so I get 3.5 groups of 2/8. And I've got 7/8 multiplied by 8/2. And that's 7 times 8 and 2 times 8, and the 8's will cancel, and I get 7 divided by 2, which I have already solved over here. So I'm starting to see some real patterns emerging here as I work through these exercises. I'm seeing that I can cancel out the units when they're the same, and I am just left with a dividend and a divisor. And when I do the division, I am finding the same quotient through division, through modeling, and through using multiplication to get to the division. All right, 13/10 and 2/10. So I've got 13/10, and I am dividing by 2/10. And I'm instantly noticing that once again I'm going to have some kind of remainder here because 13 doesn't divide evenly by 2. So I'm going to draw a model here. And I'm going to need 13/10. So I'm going to need, first thing, leave myself some room here. The first thing I'm going to do is get my 10/10. That's going to be my 1 whole. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10/10. But I also need 3/10 more, so I'm going to need a second whole. And 1, 2, 3, 4, 5, 6, 7, 8, 9. And on this one, I'm only going to need 3/10. 1, 2, 3. 3/10. Okay. So now I've got 13/10, and I want to make groups of 2. So a group of 2, 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 a group of 2. So I've got 1, 2, 3, 4, 5, 6 groups of 2. They're groups of 2, so the denominator is 2. And I've got 1 piece left over. So 6 1/2. Now I can check that out. 13/10 multiplied by 10/2. 13 times 10 and 2 times 10. Which will leave me with 13/2, which is 13/2 right here, and then I get 13 divided by 2. 6 times 2 is 12. 6 1/2. So all of my patterns are continuing to hold true. All right, taking a look at exercise 6 here. 11/9 divided by 3/9. 11/9 divided by 3/9. Which is going to leave me with 11 divided by 3. So I am predicting a 3 2/3. And come over to my model here, and I'm going to need 1 whole, which will be my 9/9. And I'm going to need a second whole because I need 11/9. 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. So this is 9/9 that I've got here. And I need to get to 11/9, so I'll need 2 more of them. So there's 2/9. Now I've got 11/9, and I'm making groups of 3. So I've got 3 whole groups of 3, and the denominator's 3 because I'm making groups of 3. But then I've got these 2 pieces left over, so I can make 3 2/3 groups, which is what my prediction was. I've got 11/9 multiplied by 9/2. Oh, 9/2, 9/3. These will cancel, and I end up with an 11 divided by 3, which is right here. So some big connections here between dividing fractions, multiplying fractions, the models. And these are called unit form when they have the same denominators. Makes things very nice to work with. So imagine that your best friend missed today's lesson. What key ideas would you want your friend to know in order to be able to divide fractions by fractions with the same denominator? So kind of what is your takeaway from this lesson? Probably, if I were a 6th grader trying to boil this down to, the simplest thing, writing it in unit form helps me see that I am going to have a dividend and a divisor. Dividend, divisor, and 3 divided by 1 will give me 3. So when I'm dividing with like units, I can just divide the numerators by each other. 3/4 divided by 1/4. I don't have to worry about these when I have the same units, when I have the same denominators. All right, so taking a look at a lesson summary, when dividing a fraction by a fraction with the same denominator, we can use the general rule A over C divided by B over C. So A over C divided by B over C. Notice the denominators are the same. I am going to have A divided by B. Now, the problems that we've looked at today have been measurement division. Now, the question, of course, is, does this work with partitive division? We were answering the question over and over again, how many groups can we make? Well, for partitive division, we'd be answering the question, how many would be in each group? So do you think that this will work with partitive division? So go ahead and think about that for a moment. Pause the video, jot yourself some notes. The answer is yes, it will. It will work with partitive division. All right, so a quick look at the ICANN statements here. I can use fraction bars, tape diagrams, and number lines. We have used tape diagrams, we've used number lines to show division of fractions by fractions when the fractions have common denominators. Fraction bars, a little harder for me to model in a Google slide presentation. Looking at connections between multiplication and division. We didn't do too much explaining today, but we definitely worked on the connection, and hopefully you're starting to think about how do these things work. And then measurement division here, deciding that the quotient will tell me how many groups I can make. So this concludes Module 2, Lesson 3. If you've got questions, make sure you talk to your teacher. Make sure you complete your problem set.